Hello, it's Keith from Kinvert, and I'm about to start heading to the Mun here and going for a landing. And I think it's going to be helpful because I lost communication with a satellite earlier, and I think that if I have a satellite in geostationary orbit, or Kerbal stationary orbit, I don't know, I think that'll help me with communication with the satellite, so I'm going to be trying to launch a satellite into a geostationary orbit so that there's always a satellite directly above Kerbal Space Center. So I'm going to start calculating that out, and yeah, I will put in a time if you want to skip this or whatever. I understand some people aren't going to like the math that much. So what I'm going to do is basically I want a velocity to equal a velocity. So one thing we can know is I don't know what is, how did that happen? What is the radius of the orbit? So the radius is unknown, right? We've got Kerbal here, and then we've got this orbit going around, and I don't know what this radius is. Alright, so I do know we can go back to Kerbal, and if we go to this thing, we can see that the gravitational parameter is 3.532 E12. 3.532 E12. Alright, so that is mu here, that's the gravitational parameter. And basically what I'm going to say is, in the amount of time that it takes to do one circle should be one Kerbal day. And that, which we just saw on the other screen, is 5 hours and 59 minutes and 9 seconds. And if you just multiply all that by the proper 60s, you're going to get 21,549 seconds is one Kerbal day. And so we've got the gravitational parameter. Alright, so basically all we're going to do is say the velocity equals the velocity. One of the velocities we know is 2 pi r over 21,549. So what we're saying, we know that we're going to go 2 pi r around, that's just the definition of a circumference of a circle, and that it's going to take us this many seconds. We know that. We don't know what the radius is yet. And now we can set this equal to the gravitational parameter, the square root of this, 3.532 E12. I don't know if this is the official way, I haven't done this in a while. And then we're going to divide this by r. This equation here, by the way, is the circular velocity. And we just want to know what radius we're doing this at. So I'm going to do this off screen on a calculator here. And what I've got is, in meters, we've got let's get this relatively exact, 3.4, because if it's off, it's going to drift away. 3.46352 E6. So this is the radius that we need from the center of the planet. So that's one thing that I need to make sure of, is that because the radius of Kerbal is 600 kilometers. And so that might need to factor in. I think that when you're in orbit, it's measuring your actual altitude, which is like, say, 70K. So what we're going to be doing is trying to get a circular orbit with basically zero inclination directly above Kerbal Space Center at this radius from the center of Kerbal. So that's what I'm going to be aiming for, and hopefully I'll be able to do that in this video. I'm also going to be trying to build this thing, so this might be a two-parter, and hopefully this communications relay is going to help us maintain communication for a moon landing of a probe. We haven't designed that probe yet. Or really a lander, I don't know. It's going to be coming back. So yeah, we need to start designing that. So I'm going to get into the vehicle assembly building and start designing this communication satellite out. Now, I think I've seen people do this with 2 satellite dishes. I don't know if it helps, but I'm just going to do that since I'm spending the time. I'm going to go ahead and open up the one that got me to the moon. Maybe this one? Yeah, I'm going to go with this one. Alright, this is an older version here, isn't it? I still think it's going to work, and I don't have to worry about part count anymore the way I used to. This is not meant to land anywhere. Of course, I tore off the solar. Alright. Is this going to click where I want? Alright, I'm going to go for... because this might be communicating a fair bit. Let's just get this surrounded with solar panels here. Oh, and I've got a heat shield. Let's pop this here. I gotta start doing some fat trimming. Do I need that? I guess I'll leave it. So I've got quite a bit of solar. I don't have enough tech to really go higher than this in solar. Communications. Get this best antenna here. And I'm gonna go with 2. Something like that. Is there anything else I really need to do? I don't think I need any science up there. This was enough to get me to the moon and back, so I don't really feel like calculating out the delta V, but there ought to be plenty. I don't probably need to hold it, I didn't used to. Not too worried about that. Not worried about landing. Does thermal matter? To help dissipate heat into space. Do I need it? So small, small, large, edge, 0.03, 0.05. Go like this. I don't know if I need it. I really have no clue. I'm gonna pop it on there. I mean, do I need to dissipate heat from these? And then what if I extend the antenna? Is it gonna interfere? Ooh. I guess the game doesn't care, does it? I don't personally care. Let's see. Oh, and it's got this old antenna. Don't need you. I don't think I need the heat panels. I can get 2 on here. And then it won't interfere. Okay, so I've got solar, I've got a battery, I've got these guys. I mean, I think I've got what I need to launch this, and this is going to be Geo 1. What else do I need? Got solar, got a battery, which I hope is enough. I really don't think I need any science. No, I mean, I really don't see anything else that we need to make this work. Let's check the delta V. I don't feel like calculating out more than I already did. That's probably enough math for one video for most of you guys. And I don't need this decoupler. I'm just gonna leave this so if I need to make any orbital changes, I can do so with this upper stage. But this managed to get me to the moon and back with a pretty lightweight satellite, so this should work. Let's see here. I can rotate these down. Go to this rotate thing. Grab it. Call that good. And then when I extend this, it still ought to go out 90. And it's not crashing as far as I can tell into anything. We've got battery, we've got control, the brain, plenty of solar. I can even throw on more solar. It's only 12 grand, so who cares? Go down to power, add more solar, just make sure this is going to be able to handle all the communication I want. Okay. Heck, even to be safe, why not? Yep, that'll work. Okay, so this should fly. We'll find out. Let's just go for it. This is correct staging. We'll look at the vacuum delta V. I think this is going to work. Let's see, we've got this original, the way this worked. I'll double check the Aero. Stable. Let's do this. So I'm going to save Geo1 and launch this. And we're going to aim to get this geostationary. Okay, full throttle, probably no stability assist, and we're going to go for it. Head to map view while the rocket is still pretty good and stable. Don't want to gravity turn quite too hard. It's a little harder than I want to do the gravity turn. It's not even listening to my commands at this point, so we might have a little bit of trouble. I do not want to be turning this hard this fast. So I'm going to be fighting this a fair bit, trying to get this up. I still don't want to be heading this way. Again, sorry for the audio. Got some family here. Alright, so I got the orbit a bit better here. I think that gravity turn just went too far and I didn't have enough control authority with the combination of my control wheel. Alright, so let's get back into map view. Alright, I might have salvaged this. We'll see if I've got enough delta V. And I am aiming for a 0 inclination, so we'll see how that goes. I might be in trouble because this last stage is probably not going to be aerodynamically stable. Famous words there. Alright. Alright, let's revert to launch, or revert to vehicle assembly. What did I have that worked better? I mean, I had I can't really load 2 at a time, so what I'm going to do is ditch all of this and save this as Geo1. And now I don't quite know what to do because I want to add from a save. Enable advanced mode. Subassemblies. Can I drag and drop a part here to save it as a subassembly? No part selected. Select a part. Subassembly. Click, 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 click. Did I just delete it? Alright, how am I going to do this? Add custom subcategory. I mean, I don't care. Jeez. This? I don't know. Okay. Geo. Whatever. Okay. So Geo. Okay. Subassembly drop zone. Drag and drop a part here to save it as a subassembly. There's no way to be one part if they're going to call it a subassembly. Click, hold, click, click and hold, click and let go, click, 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 click. The selected part is not attachable. Well, that's nice. How do I save this as a subassembly? So, okay, save that and open. Okay, maybe I can merge. Okay, so that Ferry 4, I've got a lot of delta V with that. And I could merge it. Grab. Okay, I mean, now what? Cool, I know that that's there, but how am I gonna... Alright, what if I do this? Oh my gosh. Okay, grab this off. Grab that off. Pop that there. Okay. So this used to fly better. Alright. So I'm gonna go for this. This ought to be enough delta V. 19 grand, that seems pretty pricey for what I'm doing, but whatever. Okay. This ought to get me high enough that I don't have to worry about the aerodynamic instability of this upper stage. We're off. This is basically the same rocket that I was using to ferry people for like those space tourist type of missions. Trying to stay on that 90-degree heading. Oh boy, now it suddenly turns. It just kind of decides when it will and won't turn. Alright, so now that I've got the gimbaling engine, I should have more control authority here. So I'm just gonna keep trying to turn as much as I want here. I mean, by now I'd like to be aiming a little further down. Alright, things are relatively stable. Knock on wood, so now I'm gonna go to map view. Alright, so we've got 20,000 for my apoapse, and I'm hoping to keep this at a 0 inclination. I have no stability assist or anything. Alright, how am I doing? Still quite a bit of fuel, and I've got entire extra stages here, so my inclination is a bit off, so I'm going to start pulling it over here. Maybe that'll get it centered. Not quite. I might be getting pretty hot soon. I should probably angle up a bit more. I don't have any fairing or anything on this, and I've just got some bare satellite dishes. Alright, this one is not aerodynamically stable, so I'm going to be fighting this. Can't even read that number, and I can't focus on it. Okay, 40,000. Fighting to, this thing wants to go kind of straight up. I'm fighting to keep it at a reasonable angle. My apoapsis is not raising as quick as I'd like. My speed's going up, but my apoapsis is not skyrocketing here. I gotta be on fire. I don't know, I guess not. wonder if I am going to have enough Delta V to do this. I think so, yeah. Oh, jeez. I must just have a terrible thrust to weight ratio right now. I don't think I forgot to take anything off. Alright, so yeah, I'm going to get this circularized and then start figuring out, you know, get it circularized maybe up at 100 thou. Because what, I got to get up at like 3 million or something. I don't even know where that compares with the MUN. Alright, we're still going. So now my apoapsis is finally starting to rise up here a bit. And I'll get that up to around 100 thou. I think this is, it's been a pretty inefficient burn, but I really overdid it with the rocket. This ascent took a really long time. Call it good. Okay. Now in space. And I need to be ready because I think this is a terrible thrust to weight ratio. I don't have maneuver nodes, so I'm just going to time warp. Alright, let's get out of map view, extend the antennas. Alright, we've got a ton of solar panels. Alright, I'm gonna just start burning now. Yeah, it's just quite the low thrust to weight ratio. I'm gonna end up with space debris, aren't I, if I'm not careful. Alright. Yeah, I'm gonna ditch this. Let that fall to Kerbal. Now it shouldn't hit me in the back. Correct. Alright. So let's finish circularizing this. What do we got? 55. And I want to get this up to about 100. (102), 105, good enough for me. Alright, so we're in orbit. That is suborbital. So no debris, that's good. So now what I want to do is get to the opposite side of Kerbal and then burn out my apoaps to the, I didn't write it down on the paper. So let me go back to the math. 3.46352 E6. And that probably needs 600,000 taken away. Yeah, it does. I'm assuming here. So if I do that, alright. So yep, I was right, just double checking, it just becomes kind of 2.8 instead of 3.4. Alright. So we're gonna go back into here, time warp until we're on the other side of Kerbal. Hopefully exactly on the other side from Kerbal Space Center. Let's see. I don't know how to know exactly when that is. I think it's pretty close at this point. I don't know what my inclination is, but I'd say now's the time to go prograde. Ooh. I think I'm going to be good and behind the moon. I wish there was a way to just lock it in one place. Okay. 1 million. Oh boy, is this going to be... Okay, this is going to be getting kind of close. I think it's going to stay below. Alright, and I need to aim for 2.8 million. Alright. 2.8 million, let's keep my mouse over it. .6, 2.7, 2.8, 2.863, 2.863, I'll call it there, and hopefully that's good enough. And hopefully I did all this right, so now I'm going to time warp out until I'm there. Don't overshoot. Oh, okay, I'm gonna have to stay in a slightly lower orbit, because by the time I get out there, okay, that was a little derpy. So I'm gonna time warp forward a bit, and then I'm gonna almost circularize this, but I need this to not be the full radius, or I'm just gonna stay over the middle of nowhere. So I'm gonna aim prograde. Time warp a bit more. Okay. Let's raise this guy up to about half. Something like that. And this won't calculate out my orbital period, will it? But if I've got this is like a full day, and that's going to be, let's say, a quarter of a day. So I can just start time warping until... So by the time I get out here... Okay, so it caught up to me. So it's going faster than me. So now what I want to do is raise this a bit more. All right. Okay, go prograde again. So let me think. If I do this, I'm going to be going around faster than a day. But I don't want it. Let me think. Kind of think I want to go out to about 2 million. just see how it goes. Okay, then we'll time warp and see how this turns out. And I should be faster. Yep, I am faster. Okay, I'm in the opposite side. And if I go this far, I'm going to start catching up more and more. Then I'm going to whip out there. This is my time. All right. It's not going to be perfectly, you know, straight up, but it's going to be pretty good. Getting close. Okay. So now I got to do some careful burning here and get this to the 2.8635. I'm accidentally raising my apoaps a bit. Okay, this is gonna flip. Okay, 2.83, 2.9. This is getting pretty close. So this one is too low by just a tiny amount. I should be able to time warp and basically stay straight. Oh my gosh, did I do the math wrong? No, it's pretty good. Okay. There we go. I mean, it seemed like pretty simple math, so let's see here. 2.83, I want to go to 2.86. So let's aim prograde. All right. And now I'm going to go out to my periaps and adjust my apoaps. And I should just stay over KSC this whole time. Okay. Now I want to lower this just a bit. Oh, I'm already aiming retrograde. So 2.86 is my goal. Moved 2.87. Oh boy. All right. 2.86, 2.86. Call that good. So we should now have a geostationary orbit around Kerbal. And we can fast forward a few days and make sure that it stays looking good. That's, yeah, it's staying there. Okay, so it looks like the math worked out. So it ended up at 2.86352 million meters from the center of Kerbal. Because it's... No, from the surface. 2.86 whatever million meters from the surface of Kerbal. 3.46 million from the center of Kerbal. So we've now got a geostationary orbit, and hopefully this is going to help anytime I'm going to the moon or Minmus or anything. We've got a constant data link between Kerbal and them. Even if the Space Center is occluded, it's got plenty of solar going on. So yeah, it's not oriented in a great direction. I can just kind of do this. Not that it matters. Let's time warp a bit, so hopefully it'll lock that orientation. Okay. And yeah, this should always have a view of Kerbal Space Center below. That's all I really wanted to do. These are extended. We've got power, we've got basically everything, and quite a bit of fuel left if we need to make adjustments. Cool. So We did the math. Basically, all we did was calculated our how long it should take us to get around the unknown circumference. All we were missing is r. And then we found the circular velocity. This is just something I remember from getting my aerospace degree, aerospace engineering degree. And also, the radius is unknown. And then we just solved for both sides. I didn't bother doing the algebra. Hopefully you guys already know that. But this is an application of algebra. So you're really just going to square both sides and blah, 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 and isolate r. You end up with this, which comes out to the same as, I'm going to do this with my mouse, 2.8, blah, blah, blah. And that's because of the 600 kilometers right there. So yeah, we calculated out, we tested it, it worked. We've got a geostationary satellite up there. I probably overspent quite a bit on that rocket, but hey, it's up there. We've got some extra delta V if we need it. This is Keith from Kinvert. This is probably going to be part of our online course that we're making over KSP. I'm going back and playing career mode, getting ready for Kerbal Space Program 2. And we're planning on making a class for that for kids that we teach in person. We teach a lot of kids coding, robotics, 3D printing, and Kerbal stuff like that. And this is also going to be part of that. So the next time you come back, we're probably going to go ahead and upgrade the research center and then start getting ready to actually land a probe on the moon, the Mun. So that's what we expect to be doing. We will see you guys next time. Bye-bye.